Welcome back to another lecture. Today we're going to begin talking about exponents, and there's a lot to cover with exponents. So let's begin talking about even what an exponent is. So we have an expression b to the t, and that t is going to be kind of at the top of the b, and that represents b times, etc. times b t times. So, for example, 2 to the 3 is 2 times 2 times 2, which is 8. Notice that this is not equal to 2 times 3, which is 6. So be careful not to multiply them. Make sure that you actually, I would highly recommend whenever you see something like this, you just go ahead and write out your expression every single time. That way you don't forget. That's how I learned it, and it was very helpful for me. So terminology, B is called the base, which is why I called it B. And then T is the exponent. And I use T to represent like number of times, but it's called the exponent. And so we can go ahead and work another example. Negatives are going to be maybe the most tricky in this case. We're going to do negative 7/8 squared. So remember, we're going to write out, this is negative 7/8 times negative 7/8. We have a negative times a negative. That's a positive. 7 times 7 on top, 8 times 8 on the bottom. That's going to give us 49 over 64. So negative 7/8 squared, which is negative 7/8 times negative 7/8 is 49/64. Let's do another example. Let's do 5x cubed when x is equal to 4. And maybe what we'll actually do is move this to the next page because I have something I want to show you with that. 5x cubed, we'll do this, 5x all cubed when x is 4. So what this represents is 5x times 5x times 5x. And so maybe whenever we plug in 4, we're going to get 5 times 4. I'll go ahead and write it out. 5 times 4 times 5 times 4 times 5 times 4, which is 20 times 20 times 20. That's 8 with 3 zeros. Okay, so 5x cubed when x is 4 is going to be 8,000. Notice that is different than 5x cubed with no parentheses, because what that represents is 5 times x times x times x, which is 5 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 5, I don't know that one off the top of my head. It's going to be 20, carry the 2, 30, 320. So notice that these two things are not equal, meaning that these two things are not equal. So be careful with that. There's lots of very subtle nuances with exponents, so you have to be very careful with them. So in general, we can actually say that a x to the n is not equal to, and this is, of course, in general, not equal to a x to the n. So 5x cubed is is not equal to 5x cubed. Okay, and another particularly important example is negative, let's say 3 to the n is not equal to negative 3 to the n, because over here on the left we have negative 3 times negative 3. Let's say n is 2, for example. That would be negative 3 times negative 3. And over here on the right we have negative 3 times 3. And you can see on the left we have positive 9, on the right we have negative 9, and those are not equal. So that brings us to the first rule of exponents that we're gonna learn. It's the power rule, or the product rule. If you have x to the power of a, we multiply by x to the power of b. That's going to give us x to the power of a plus b. And we can see this pretty easily. Let's say 5 squared times 5 cubed. Well, on the left-hand side, this is, well, I'll go ahead and write it over here. That's 5 times 5 times 5 times 5 times 5. By the associativity property of multiplication, we don't need parentheses. And that is 5 to the 5, which is 5 to the 2 plus 3. So that's kind of why this particular property works. Is that if we have, go ahead and do it in general, x to the a times x to the b, that's x times x times x a times x times x times x b times. By the associativity property, that gives us x times x times x times x times x times x. A total of, that was a really bad bracket. There are a of these, there are b of these, so in total that gives us a plus b of those. So that's x to the power of a plus b. Okay, quick note, this does not kind of apply the other way around. A plus b to the power of x is not equal to a to the x plus b to the x. Let's look at an example. 2 plus 3 squared is equal to 5 squared, which is 25, whereas 2 squared plus 3 squared is 4 plus 9, which is 13, and those two things are obviously not equal. Okay, let's do the power rule now. That says if you have x to the power of a all to the power of b, that is equal to x to the power of a times b. And again, this is relatively easy to see. Let's do an example. 5 squared cubed. That is 5 squared times 5 squared times 5 squared, which is 5 times 5. I'll put in parentheses here. Times 5 times 5 times 5 times 5. By the associativity property, don't need the parentheses. How many are here? There are 6. So that's 5 to the 6, which is 5 to the power of 2 times 3. So that's why, or that's an example of this rule working. Okay, one more thing on these exponents. If you ever see, well, one more thing, we have a lot more things, but if you ever see a number to the power of -1, that is equal to the reciprocal of that number. So for example, 5 to the -1 is 1/5. 1/5 to the -1 is going to be 5. well, let's kind of derive that. That's 1 all over 1 over 5, which is 5. And maybe we drive that even further. 1 is 1 over 1, all over 1 over 5. Multiplying or dividing fractions, you flip the second and multiply, and you see that's 5. Then I guess we can look at x to the power of negative n. Well, notice negative n is negative 1 times n. Negative 1 times n, we know from our previous property here, if we set a to be negative 1 and b to be n, you can see that we can write the right-hand side as what we had before, and the left-hand side is going to be x to the negative 1 to the n, right? So we can do that here. That's x to the negative 1 to the n. We know what x to the negative 1 is. That is 1 over x to the n. And we could also write this as x to the n to the negative 1, right? Because these two things are true, right? Because of the commutativity property of addition. So we could kind of write it the same way. They're exactly the same. That's 1 all over x to the n. So we actually just derived here, x to the negative n is 1 over x to the n, and also 1 all over x all to the n is the same thing as 1 over x to the n. So we get kind of a 2-for-1 there, just using the commutativity property of multiplication. So everything we've kind of learned up to this point is really starting to play a role, in particular the properties of the real numbers. Okay, x to the power, or x times y, all to the power of n. Let's go ahead and derive this. Well, first I'll tell you what the rule is. X to the n, y to the n. Remember, this didn't work for addition, but it does work for multiplication, and here's why. xy to the n is xy times xy n times. That's a terrible looking n. N times. That is going to give us, we can use the associativity property and just bring everything together. xy, xy. Right, we don't need the parentheses because all of it's multiplication. Okay, we can use the commutativity property now to put all the x's together. And I'll go ahead and invoke the associativity property as well. Y. Well, remember there are n of these and n of these, so that's x to the n times y to the n, as we wanted to show. Okay, let's do some more. I know we're really going through these quickly, but it'll be very important that you practice these, and that's really how you'll learn them and really get the feel for them. We'll do x divided by y to the power of n. Well, remember we said before that, well, maybe we'll do an intermediary step. That's the same thing as x times 1 over y, right? To the n. So we know from before 1 over y is y to the negative 1 to the n, and we can invoke the previous property. Remember this one. Sorry. Invoking the previous property, we can split that across multiplication. And then we can go ahead and simplify a little bit. Y to the negative 1 is 1 over y to the n. And remember that is the same thing as 1 all over y to the n. So then multiplying these two together, you get x to the n over y to the n. So in general, x over y all to the power of n is x to the n over y to the n. And that just follows from the previous rules that we've learned. Okay, that was a lot. Let's do some examples, and then we'll recap at the end. Simplify -7 to the 4th b squared. Okay, so -7 to the 4th b squared. Well, remember that squared means we're multiplying twice. We can use the associativity property to get that that is -7, and I'm going to put -7 in parentheses here, a to the 4th b times -7 a to the 4th b. Use the commutativity property to get that we have -7 times -7 times a to the 4th times a to the 4th times b times b. -7 times -7 is 49. A to the 4th times a to the 4th, remember, is a to the 4 plus 4. And then b times b is b to the 1 plus 1, right? Because b is the same thing as b to the 1. So this is 49a to the 8 b squared. There's another way you could have done that. And we haven't proved this, but I think you'll see that it's true. We can split this up into -7 squared using the multiplication property times a to the 4th squared times b squared, which is 49 a to the 4 times 2, b to the 1 times 2, which is 49 a to the 8 b squared, just as we had before. Okay, let's simplify. -1/3 to the -2. Okay, remember that -1/3 to the -2 is going to be -1/3. Let's see, which one do we want to do first? It's going to be to the -1 times 2, which is -1/3 to the -1 all to the power of 2. Well, this one in the middle is 1 all over -1/3. And we keep the squared on the outside. That's -3 squared, which is 9. Maybe I'll do one more step there. It's -3 times -3, which is 9. Let's simplify. B to the power of 8 all over b to the power of 18. Okay, so b to the power of 8 over b to the power of 18 is the same thing as b to the 8 times 1 all over b to the 18, which is the same thing as b to the 8 times b to the 18 all to the power of -1, which is b to the 8 times b to the -1 times 18, which is b to the 8 times b to the 18, negative b to the 18, sorry. And so then using the additive property of exponents, we add those two together, which is the same thing here as subtraction. We're adding the negative b to the -10, and that is 1 all over b to the 10. Notice that these look like long and complicated, but really what you're doing, kind of the simple way of doing this, and I'll notate this in green just to show you it's kind of simpler. we get 18 minus 8 is 10. So once you get like good at these exponents and you understand them, you'll be able to do these pretty quickly. All right, another property. Anything to the power of 0 is 1. This is maybe unintuitive at first, but just kind of go with it. Anytime you see anything to the power of 0, you just replace that with 1. So 3a to the 4th b to the 0 c is going to be 3a to the 4th times 1 times c, which is 3a to the 4th c. Okay, so this is a very important property. We can derive that if you want. Let's derive it. X to the 0, and I should note, x cannot be 0 in this case, because then you would get 0 to the 0, and we don't know what to do with that. And whenever I say we, I mean like mathematicians. There's no way to define that in a consistent way. Right, because let's talk about that for a minute. Before we prove this property, let's talk about it. 0 to the 0. On the one hand, it's 0 to the power of something, which means we have 0 times whatever, 0, however many times, which is always going to be 0, right? On the other hand, we have 0 to the power of 0 being something to the power of 0, which should always be 1. And 0 is not equal to 1, so there's no consistent way of defining it. So, in general, not in general, always, we just say no to 0 to the power of 0. Okay, now let's derive this. So take x, and we're going to assume anytime you see x to the power of 0, at least whenever I'm writing it, assume that x is not 0. X to the 0, well, take your favorite number. It could be whatever number you want. We'll call it a. And 0 is just a minus a, right? Because any number minus itself is 0. Well, we know from before this is x a plus negative a, which is x to the a times x to the negative a, which is x to the a times 1 all over x to the a. And you can see anything divided by itself is just 1. So that's why x to the 0 is 1. We'll do one more example, kind of putting all this together. We'll do a quick recap, and then we'll be done with this with exponents. So let's simplify. (5x to the negative 2 times y all over x cubed times y to the negative 1. Okay, this is going to put together several things that we've learned. The first thing I would do on this is take your fraction and rewrite it with exponents. So 5x to the negative 2 times y times x cubed y to the negative 1 all to the power of negative 1, right? And if you need to review this negative 1 power and how we got this, just go back a little ways in this lecture and review that. Or if you have any questions, of course, email me and I can help you, or come to office hours, that's fine too. So that, let's go ahead and do some distribution. So that 5x to the power of negative 2, we know from before, that's 5 to the negative 2 times x to the negative 2. And then we still have the y in there, and we can distribute that negative 1 and get x to the power of negative 3 times x to the power of negative 1 times negative 1 is 1. 5 to the negative 2 is 1 all over 5 to the 2. X to the power of negative 2 is 1 all over x squared times y times x to the negative 3 is going to be 1 all over x cubed, then y to the 1 is just y. Okay, so now we can combine all these as a fraction. It looks like the numerators is going to be 1 times 1 times y times 1 times y, which is y times y. Denominator is going to be 5 squared, which I'll put together as 25, times x squared, times 1, which is implicit here, right, times x cubed, times 1. Okay, y times y is y squared, all over 25 x squared times x cubed is x to the 5th. Okay, let's recap. B to the t is b times dot 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 times b t times, where t is some integer greater than or equal to 0. No, it doesn't even have to be greater than or equal to 0. It could just be, well, yeah, greater than or equal to 0. That's this intuition, but you know what? We'll just ignore that. So we learned first that, what was it? It was x to the power of a times x to the power of b is x to the power of a plus b. And then we learned that x to the power of a all to the power of b is x to the power of a times b. We use that to derive the fact that x to the power of negative n is going to be 1 all over x to the n. We learned that x times y to the power of n is x to the n y to the n. And we learned that x to the, well, I guess we can include division there. X over y to the n is x to the n over y to the n. And then anything to the power of 0 is equal to 1, except 0 to the power of 0. So these are the rules you need to know about exponents. All right, next lecture, this has basically been a crash course in exponents. So the next lecture, we're going to work on scientific notation, which is going to be heavily using exponents, and then we'll move on to polynomials. All right, as always, if you have any questions,